Hi everyone, and welcome to another episode of Mr. Carlson's Lab. Let's get started. I very much enjoy troubleshooting modern electronics and older electronic devices with older pieces of test equipment like this. It is a lot of fun. I guess you could say it adds another level of challenge to the find. And of course, you know me, I love all things electronic. So if you're new to this channel, you'll find me working on solid state stuff with surface mount technology all the way back to this old vacuum tube stuff. You'll see lots of restorations and repairs on this channel. So what I'm doing, I guess you could say the scope of this video is to verify whether this thing inside is a charcoal briquette or not. The back side of it has a line cord that's been cut flush with the case. So that's usually the line cord is just in very bad condition and, the seller of the device doesn't want anybody plugging it in, or the power transformer inside is cooked. So I want to verify that today in this video. And of course, if that power transformer inside is okay, then I will go ahead and do a future restoration on this and I'll take you all along on the journey. And then of course, down the road, once this is restored, I will also show you how to troubleshoot modern electronics with an old piece of gear. This is still a very valid piece of test equipment, even though you can pick something like this up from a swap meet for $5 to $10. So they are a lot of fun to use. Now, I need to get this thing apart so we can take a look inside, and that's the next thing here. So I'll grab a screwdriver over here, and I believe I'm going to have to take all of these screws out of the face. I haven't been inside this thing, so we'll discover this together. Ooh, that seems to be kind of... I think this might be part of the bottom. I might need to put those back in. So again, we'll discover this together. Who knows what's going on inside this thing. There are also 2 screws on the side. There should be more, but there are screws missing in the case. So of course, this thing being this old, it's bound to have had some hands in it at some time. So there's something very neat about this oscilloscope, which another thing that attracted me to it. So I'll show you the little tag on the back side of it here. And you usually don't get that tag on a piece of equipment unless it's a pretty high quality piece of gear. So I'm just going to put this down here just in case this bottom is separate. I don't want anything falling out or anything like that. Is it? Yeah, it kind of feels that way, doesn't it? So what I'll do is I'll take out the 2 screws on the side here, and hopefully I can do this on camera. So these 2 here. Each one of these things, they all go together and come apart in different ways. There's so many different old scopes. Some of them, they slide out the front. Some of them, the top comes off. Some of them, the bottom comes off. I'll show you this little tag here on the back in just a moment. And you'll see what I mean here in just a moment. It'll be easier when I can lift the case off this thing and show you that way. Or pull the front out or whatever. You got to be careful with these handles. Another word of advice, if you ever find one of these things at a swap meet, a lot of the times these old handles, they're very fragile, and if you try and lift one of these things, they'll snap and your piece of equipment that you've just purchased will fall on the floor. So you got to be very careful with these. This one here, it looks like it's pretty tough still, but there we go. I don't want to take the chance. I'll get that out of the way. Oh, look at that. Wow, that is really well put together. They've even gone as far as to shield all the circuitry in here. Look at this pipe. The thickness of that pipe. So a big magnetic shield there to stop interference from bothering the CRT. So, because these are, of course, CRTs are magnetically deflected, right? And this one here happens to be electrostatically deflected, but it'll get deflected by magnetism. So this is put on here to stop any stray magnetism from affecting it. So look at the thickness of this. Big chunk of pipe. Usually this is mu metal. I don't know if you can see that. I hope that's not too bright. This big, thick piece of pipe. So in order to get to the circuitry in this, I'm going to have to probably remove the CRT and take this cover off. Boy, they sure went to some lengths to shield this thing. Line cord down here. Look at that. That's pretty bad. Looks like it actually has been... Yeah, that's pretty bad looking. Right flush with the case. Okay, so here's the interesting stuff. I'm going to have to move this off to the side because the microphone is... It's a Sylvania Stromberg Carlson model 131 AM. So this is a Sylvania model 131, but in the Stromberg Carlson world, this is a 131 AM. Now, you usually don't see this tag on something unless it's built very well. And I can already tell by the looks of the inside of this thing that they've definitely done their research. So yes, the face on this thing here, you can see is connected to the bottom panel. So, and this bottom panel is a piece of it. So what I'm going to do right now, before I go about damaging anything, is I am going to put those screws back in. There they are. So I'll put these two screws back in these bottom holes here so that the face is part of the... hopefully I can find where they went. I think that's it. There it is. Let's put two screws in there so that'll hold everything nice and solid. As I say, each one of these things, they all come apart differently. So tighten those up. There we go. Now it's solid. I can move this thing around without having the face move separately from the body. Look at this, they're using Loctal type tubes. Where's the button? Where is the button? The button is on that side. So with Loctal tubes, these things lock in place. All right, so they're not like this. This is an Octal, but what they've done is they've actually put a retainer here because all the tubes are hanging inverted. So, you know, of course, in any type of rough application, these would want to wiggle and fall out, right? So they've used Loctal tubes, which are really neat. So they have a button on one side of them, and in order to get the Loctal tube out, you always push towards the button, and then they pop out. And there's a little locking ring right here. You see that? So see the button? So what you do is you always feel the base until you find the button, and then you push the tube towards the button, and then they'll pop out. So a little trick for you there about Loctal tubes, and they just pop back in. They're nice and sturdy, really good for rugged application. A lot of people don't like Loctal tubes because of the... I'll just pop this out again here. They don't like them because of the small pins, but the contact area in a lot of the better sockets is just fine. They use these things in automotive application a lot, you know, in car radios, because of course, you know, you're going down bumpy roads and things like that, and the tubes didn't fall out. So, yeah, just a neat application that they created for it. They have smaller pins than the Octal tube. So this is a Loctal tube, and then a tube with a base like this is known as Octal. So Octal and Loctal. So these are always really tough to get out because of those fingers. So what I'll do is I'll just press this here and rock this out, and hopefully this will let go. Boy, I think these tubes are probably all original. And of course it's pinching my finger up against the capacitor here. So that this is known as an Octal tube. Okay, so this also has a locking pin with an index on it. So this will only allow you to put the tube in one way. So what you do is you put the tube on the socket if you don't know where it is, and you carefully rotate this, and then what it'll do is once the locking pin finds the little index there, it'll pop in a little bit, and then you can rock these back in. So the pins don't touch the base when you're doing that. It'll hold the actual pins away from the base. You can see that. So you don't actually touch the pins on the base at all. And then as soon as you find the index, hopefully you can see this here. See how it just popped in? All right, so this is no pins touching, and then see that? Just like that. And then these retainers, what they do is they bite the side here, and by biting the side, they hold everything in place when this thing goes back in. So I'll push this back in nice and carefully. And see this? Boy, those are, as I say, I think this is original. I don't know if this thing has even been touched. The tube says Sylvania. That has green writing, so I imagine that's Sylvania. I didn't look at the writing. Yeah, that is Sylvania. Yeah, Sylvania, 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 Sylvania. And I didn't look at the writing on this one, so what's it without taking it out again? Well, that one, that looks like it could be Marconi or something. Oh, what is it? Yeah, I can't tell. The writing is red, which is usually Marconi or Westinghouse. I wasn't looking at that. So the next thing to do really is I'm going to separate this cord a little bit. I'm going to, looks like somebody may have already tried to power this up. It looks like it's missing some insulation here. Interesting. So what I'm going to do is I'm going to separate this just like so. And I'm going to get some alligator clips and I'm going to attach this to my current limited isolation transformer and variac supply. And the transformer doesn't look too bad. I don't see tar oozing out here. Usually when you see tar oozing out, see if I can zoom into that a little bit. It is dark down here. So usually when you see tar oozing out a little hole there, it is a bad situation. It is dark. The wires are very dark up to about this point. So yeah, who really knows at this point? So I'm going to get a cord onto this thing. Let's give it some power and see what happens. And then we'll open this up and take a look at what's under here. Lots of wax capacitors. They all have to go. They're all bad. This looks like a sealed tight capacitor here. I always say sealed tight to keep the leakage in. So they are very leaky capacitors, and you know, all the old electrolytics. You see the sealed tight. It's usually a blue case on it like that. They usually say sealed tight. You can't see it here, but when we open it up, I'm sure we will. So all the electronics are shielded. This is like nothing on the bottom. Yeah, that's a really nice design. I like that. You know, they've really done their job to try and make this scope, you know, silent at any rate. So probably very low frequency. Yeah, I think it was 40K was the top end here. You see that 40K? So yeah, very low frequency, but still very neat and very valid. You test all sorts of things with this. You just got to know how, that's all. And I'll show you guys all how to do that. And of course, I have lots of this stuff up on Patreon as well. I have 140 plus videos there at this moment. So if you're interested in learning more about this kind of stuff, and I also share a lot of custom built pieces of test equipment that I've designed up there as well. So you may want to check that out up on Patreon. So I'll talk more about that in the end of the video. I have the scope attached to my isolation transformer and current limited variac supply, which we'll take a look at here in just a moment. And what we're going to do is power this up very safely. So what I'll do is I'll put the isolation transformer and current limited variac supply right at that corner of the screen there. And I've turned the intensity control off. I noticed that it was pointed at 12 o'clock. This is also the on and off switch. So we'll start this in the off position. So I'll turn this on and you should see a slight glow of the bulbs. And then when I turn on the intensity control, if this is drawing any current, those bulbs should light up just a little bit more. So pay attention to the bulbs right now and I'll turn this on. And they have lit up just a little bit more. Now that's still pretty dim to my eyes. It might look a little brighter than it actually is in the camera. If there was something really wrong, that would get very, very bright. So far we're looking okay. The bulbs are still very dim. And I see something going on right here. You see that? So that is a good sign. So we do have high voltage and we do have everything inside the scope. The power transformer is working. So let's see what happens here. So where's our vertical? Vertical centering. There it is. And there's quite a line. So vertical gain. Doesn't seem to do much, does it? So I turn this down. This is direct down here. So that would mean directly into the vertical plate. So that should go to a dot. And this is with the vertical amplifier on. And it doesn't change, which is usually the sign of a bad capacitor. Let's see if it actually does have any vertical deflection. It does. So that's probably hum that it's picking up right now. Possibly. So... and it doesn't seem to be any horizontal happening here whatsoever. Horizontal gain. Nothing. Horizontal centering. Wow, nothing's going on there with the horizontal. So something funny with the horizontal happening here. But the scope is alive, and this is enough just to know at this point if it's, you know, worth rebuilding. And of course, right now it's definitely worth a restoration. So that is a very, very good thing. So right now this is at a reduced line voltage, and I'm absolutely fine with that. It's got a nice bright, I guess you could say, let's see what this is. Oh wow, there's still quite a bit left. Look at that. Bit of a burn in line right in the middle of the CRT here. Kind of hard to see because of the, kind of hard to see. I'll move this with the vertical centering up and down. You kind of see a bit of a line there. See how it's a bit dark? You can actually see that there. Might be a little bit difficult to see. There you can see it there. There's a bit of a burn line across here. So that indicates that this has had a line across it for a very long period of time. Not a big deal. It's just a little bit dimmer there. You can see just me touching the screen. See, these are electrostatically deflected. You can see even me just touching the screen is causing a bit of deflection. See that? So if I moved fast enough, I could actually make this work. But I doubt that's going to happen. All right, so let's find out why we have no horizontal, which is really odd here. The fact that it won't even center almost looks like there is missing voltage or something on that plate, which is really kind of odd. So I'll move this around and we'll take a look for that. And we'll also open this thing up and take a look underneath that plate and see what's under there as well. Well, I must need a little bit more coffee today. As soon as I move this off to the side, I immediately noticed this. So, and this lug here is unsoldered. So I have a feeling that this might be the reason that we're not seeing any type of horizontal happening. So if so, that is a nice, easy fix for now. So what I'll do is I'll look for an alligator clipper, something on this other bench here. Find it in a little rubble. I do. Okay, so let's just connect this up and see what happens. That should be okay. All right. Just move this, pardon the shaking of the camera for a moment here. Turn on the transformer here again, isolation transformer and current limited variac supply, and see what happens. Are we going to get anything? Oh, I do see something. Oh, and there is a line there. So yeah, definitely it was unhooked. All right. That down there. And we'll see, this is in the off. There we go. Okay. Yeah, so we definitely have horizontal deflection now. So definitely something interesting happening here. Look at that. Lots of it there. The focus is right at the end here, so obviously some resistors are most likely out. Having this focus nice and sharp should usually be right at the center. You can go either way. So let's see, a gain and movement here. So move this around, yeah, and then the horizontal gain is right here. So when you reduce the horizontal gain, it will also get a lot brighter because it's not spread out so far here. So that's interesting. That's looking pretty nasty. So I think, yeah, it looks like something's coming into the vertical. Let's shut off the vertical gain. It has an off switch here, and that should become a flat line. It's probably hum happening. Yeah, see, there you go. So there's bad capacitors, things like that going on in here. So there it is, nice and slow. Lots of old leaky capacitors happening in this thing. And then we can increase the horizontal gain here a bit. Not much is going to happen there. Of course, we would need to have the horizontal on to do that, right? And there it is. So yeah, when we have the vertical on, you can see it's inserting a signal there. So most likely power supply hum or heater to cathode leak, something like that. Something's getting into the vertical section. It doesn't change much, which tells me that it's most likely power supply hum or something like that. Again, could be a whole bunch of things, just guessing at this moment. So at least, there is horizontal there. So it's pretty much working. So I'm thinking maybe somebody disconnected this in an attempt to try and troubleshoot this possibly in the past and maybe didn't figure anything out. Who knows what they were doing? Maybe a quick patch. They just fed a signal into the horizontal plate there. I really don't know what they're doing. So kind of interesting. All right, so what I'll do now is I'll just disconnect all this stuff and let's remove this plate and see what's on the underside of this, see how they put this thing together. Getting this thing apart looks like it might not be too bad. If I remove these two screws and the two screws on the other side, I think this whole plate and the CRT should probably come out. Worst case scenario, I could always push the CRT forward. It's just held tight by these little rubber bushings here against the face of the scope, and they're nice and soft still, which is kind of interesting. Those rubber bushings still are good. Okay, so let's remove this, and see what happens. Kind of nice that I don't need to remove everything here. These scopes all have high voltage in them because they're vacuum tube operated pieces of equipment. So, word of caution if you're new to this stuff. You want to look into it before you start working on stuff like this. If you're following along, you're doing so at your own risk. Be careful. Look at that. It is pretty easy to get apart. At least to this point anyways. Getting it past this point, maybe I need to undo those two bottom screws on the face of the unit here, and that'll allow me to move the face forward just a little bit so I don't have to put so much stress on everything here. It'll allow me to get everything out of the way. So remove that. Hold that tight for a moment. Okay. Is that going to come out? It does. Look at that. You can move this whole thing out of the way, kind of like a big door. I don't know if you can see all this. Probably not. See, that's like a big door here. I can just move this up and out of the way. So I'll just put this carefully back over here like this. Put that down on there like so. Very softly. So look at all these wax caps that need to go. I'm going to relocate the camera here so we can take a better look at this. I'll be right back. Here's a closer look at the underside, and it's put together nicely. As we can see, we have a bunch of paper and foil capacitors all over the place, here and here and here, here and here and here, over here, here. They all need to get replaced, because these are all issues in here. If you ever see a capacitor like this that says ground on it, this is a paper and foil capacitor, but it has a ground end. The ground end is the same as the outside foil and denoted by a line. So that always goes to the lower impedance portion of the circuit. And as you can see here, sealed tight. There it is. Sealed tight to keep the leakage in, and it's kind of bubbling on the end. So there's definitely been some issues with this capacitor. So this is the reason that the trace is, looking the way it does on the screen. And of course, the electrolytic and this filter over here are most likely going to be in some form of failure mode as well. Aside from the resistors that might be failing, these are all roundy style. The earlier style than the squared off ended Allen Bradleys. So these ones here, let's see if I can zoom into this a little bit more. And I'll just do this, zoom on in, focus that in. So these are the squared off ends here, so a little bit more resistant to moisture. These ones here attract moisture, or I guess you could say soak it up a little bit easier. And then of course the values change. They're not sealed like these ones are. So these are a little bit better at dealing with moisture ingression, whereas these ones here, they drift in value in any type of, I guess you could say, atmosphere where there might be moisture. So say this was kept in a moist basement or in an attic or something like that, where, elements might not be quite perfect. These will get affected by that, where these are a little bit more resilient. So these are the squared off end Allen Bradleys, carbon composition resistors, both of these. So all of these need to be checked and verified at this point. And it looks like some form of adjustment here. I'll just move this back out and touch up the focus. Pardon that for a second. So there's some form of adjustment here, probably to either adjust the vertical gain or something like that. Who knows at this point. When it comes to actually rebuilding this scope, I'll look for all of the schematics and everything, and we'll go over the schematics together, and I'll show you how everything works inside of this. If you're interested in seeing this scope be rebuilt or restored completely, you can let me know in the comments below. And if there's enough people that say, yeah, hey, let's do this, I'll go ahead and put this on the bench here, and we'll methodically go through this thing and make it work like the way it did when it rolled off the factory floor. Maybe even just a little bit better. Who knows? So there you go. That's basically what's inside this thing. Not a whole lot. This paper, look at this. It's even actually, I can rotate this right on top of the capacitor. The capacitor's not moving, just the paper sleeve is. So there we go. Nice little scope design. Hope you enjoyed. If you're enjoying my videos, you can let me know by giving me a big thumbs up and hang around. There'll be more videos like this coming in the near future. We'll be taking a look at vacuum tube and solid state electronic devices alike. So if you haven't subscribed, now would be a good time to do that as well. If you'd like to be notified as soon as I post a new video, don't forget to tap that bell symbol. If you're interested in taking your electronics knowledge to the next level and learning electronics in a very different and effective way and gaining access to many of my personal electronic inventions and designs, you're definitely going to want to check out my ongoing electronics course on Patreon. I'll put the link just below the Show More tab below the video's description, and I'll also pin the link at the top of the comments section. So if you click on the link, it'll take you right there. All right, until next time, take care. Bye for now.